Hello everyone, I am Atul Negi and I welcome you all to IMS Gate Academy YouTube platform. Today as a part of Gate Booster series, I will be taking a session on engineering mechanics that will be common for both mechanical and civil engineering students. So the purpose of this session is to revise the entire engineering mechanics important concepts in this 3 hours of session. We will be solving important questions that will help you to build a confidence in the engineering mechanics subject for the gate examination. In gate examination, concepts are very important. We need to understand the concept from the basic level. If you have a clear understanding of a concept, you can solve any problem related with the concepts. So with problems as well, we will be discussing the concepts so that you will have a complete command over the entire topics of engineering mechanics. In the gate examination, only 2 months are left. This is the right time you should start your test series as well. And you need to practice some different variety of questions. I hope many of you already solved the PYQ questions. But in PYQ questions are not sufficient, are not enough for getting a good rank in the gate examination. Yes, although you will get an idea about the level of question, the type of questions in the gate examination, but to have a good rank in the gate examination, if you really want to score a good marks, you need to practice different set of problems so that you will have a good confidence over the subject. Not only in engineering mechanics, in all the subjects, you should practice different variety of problems. That is what very important in the gate examination. Because in the gate examination, every year you will find it different types of questions are coming. So we have to prepare ourselves for different types of questions as well. So if you just stick to PYQ, you will be able to get a good score. But not that good score which is really required for getting a job in PSU examination. If you really want to go for a PSU examination, you should at least score more than 70 marks. So for that you have to try the different set of problems. And through test series, you will be getting all those different set of problems. And specifically in the YouTube sessions that we are conducting in Gate Booster series, we are taking a different set of problems, different from the PYQs. So all these problems in today's session you will get that will be very much helpful for your gate exam preparation. Not only in engineering mechanics, all upcoming sessions in all the branches, you will be getting different set of problems. Right. So we'll get started in this session. Hi Matan, a very good evening. We'll start the session. Okay, we'll first look at the topics that we are going to cover here. So if you see the syllabus, we have equilibrium topic, then we have truss, friction, centroid and moment of inertia. Then we have vibration. Vibration is there in the civil engineering, engineering mechanics subject syllabus, right? It is there in mechanical as a different topic in theory of machine subject, okay? Not in engineering mechanics subject. This vibration comes in civil engineering, right? But for a mechanical students, already we will discuss in theory of machine as well. Then dynamics and Lagrange equation. So if I talk about with regards to civil engineering first, vibration is the most important topic and as well as the truss and friction part. Truss, friction and then vibration. In the last year, if you see the questions coming from the vibration, these are like very good problems they've asked. So if you have a basic fundamental knowledge of the vibration topic, if you have attended the class lecture live, online or offline, you will be able to solve all those vibration problems in engineering mechanics of civil engineering syllabus. Right. Now coming to the mechanical part, dynamics is very important. And you will see maximum questions are coming from the dynamics part. But the problem is many students are failed to understand which kind of which formula we need to apply, which relation we have to use in the problem. So please understand in engineering mechanics, the very important part is to understand the question, to understand what kind of motion is happening. If you have understood the motion, then you can apply the equations associated with that particular motion and you will get whatever the answer, whatever the unknown they are asking in the question. All the answers you will be able to solve. Right. So that is what very important part to, you need to understand the question, you need to understand the motion that is happening in that particular question. Because if you have understood question, then everything become easy for you. Right. So we'll start with the equilibrium topic first of all, guys. In equilibrium, a small concept I want to discuss here that will be helpful for you to solve questions, right? So first of all, if I talk about equilibrium, what do you actually mean by equilibrium term itself? Can anyone tell me what actually equilibrium means? So whenever equilibrium word comes to your mind, what is the first thing you will understand about the equilibrium? Can I say it is a state of balance? Now if it is a state of balance, then balance with respect to what? So in mechanics we are talking about forces and the moments. We will be talking about force and moment, right? So force balance and the moment balance. If forces and as well as moment are going to be balanced, then the body is considered to be under equilibrium condition, right? So let us discuss that part. Equilibrium equations or equilibrium condition. Equilibrium condition. What is the equilibrium condition? So basically two types of force system we have: concurrent force system and a non-concurrent force system. So for concurrent force system, there is part A, concurrent force system, and the second part is non-concurrent force system. Right. So in concurrent force system, we have only two conditions or two equations of equilibrium. First of all, what is concurrent force system? If I talk about concurrent force system, it means the point of application of all the forces is same. Whereas in non-concurrent force system, the point of application of all the forces are not same, right? So in this case, we need to understand what kind of equations we need to apply. Right, so if you write here equations, summation of forces along x direction 0, summation of forces along y direction 0, these are the two equations. So we will see the numerical from it, okay? But before using this equation, you need to understand the force system acting on the system. If you have understood the force system is concurrent, we will use these equations of equilibrium. If the force system is non-concurrent, which means point of application is different, so we'll be using the non-concurrent force system equilibrium conditions, which is summation fx0. First two equations are same actually. Summation fx0, summation fy0, and summation of moment 0. These are the three equations we will be having. Now summation of moment you have to take about that particular point. Okay, now I've seen many times they are confused ki where we have to take. If I've assumed the equilibrium of a whole system, I can take the moment about any point. Because the concept is, what is the concept? If the net moment is exist, then there is a tendency of rotation. And if tendency of rotation is there, how you can say the body is under equilibrium condition? That's why moment, summation of moment 0, you can consider about any point, right? So you should write here about any point. So you should not be confused ki where we have to take. About any point, right? So you have to understand the given force system. Accordingly, you have to write down the equations of equilibrium, and then whatever unknown they have asked, you can easily solve. So let's get started with the first problem, everyone. This is the first problem, okay? Now, what they are asking, determine the magnitude and direction. Direction means that theta value they are asking of the minimum force P, the minimum value of force P needed to pull 50 kg roller over the smooth step. This 50 mm step is there. What is the minimum value and that direction? Direction means what? This theta value they are asking. What will be that theta? Now, please everyone try to solve this question and tell me your answers. I will give you the 3 minutes for this particular question. And that 3 minutes is actually more than sufficient to solve this question. Okay, so you have to be very quick in solving these questions. Everyone please try. Everyone should try this question, and please let me know your answers in the chat box. Okay, everyone should try this particular question. You might have solved such kind of questions also in your classes. So I don't think so that you will find it difficult to solve such questions. The problem is theta, how to calculate that theta. So for that there is a very important concept of moment is also there. That is what needed to solve and this particular question. So everyone please give it a try to solve this question, and please mention your answer in the chat box. So 2 minutes is left now. Just you have to think about, they have mentioned the minimum force P. When the force will be minimum? When it is producing the maximum moment. Maximum moment it would be producing, because actually this P is creating a rotation here, na? So it should produce the maximum moment. Then only the force will be minimum. When the moment will be maximum? When the force moment value will be maximum? That is the question, that is the point we need to understand in this particular question. So everyone please give it a try, and if you have solved whatever answer you are getting, please mention in the chat box. Okay. Everyone please write your answers in the chat box. Last 1 minute left. Last 40 seconds left, guys. Everyone, please try this, like a very basic question. I know maybe you are having a problem or facing difficulty in finding the theta value. So just think about it, minimum value of force. Why they have mentioned minimum value of force and how we can calculate that minimum value of force. Please everyone think about it. Last 10 seconds. Time up. So, okay. No issue. We'll discuss the solution. Please understand. In this session, we'll be discussing different set of problems, right? And with every problem, you will get 1 or 2 more concepts here. And I want you to write down every question and solution part here. You should take your notebook, you should have a calculator with you. You should note down all important concepts that we are going to discuss. And I'm telling you this, all concepts are very much required in our GATE exam preparation for this engineering mechanics subject. So if you have taken the notes from this particular lecture, it will help you in your exam, right? So let us understand. They're asking the minimum value of force needed to pull this 50 kg roller. Now, to get the minimum value of force P, it should have a greatest or the maximum moment value. How we can say? See, for minimum value of P, moment should be maximum. Moment value at B should be maximum. Then we can say the force is minimum. If it is creating a maximum moment at point B, so that point B we are saying this point. Okay, let me use the color, this red. I hope you are able to understand this point B basically. It is having a contact at this point with the step, right? At this point it should create a maximum moment. Now when it will have a maximum moment? Try to understand when it can have a maximum moment. When P is perpendicular to AB. AB means that distance, AB distance. Let me just draw the AB distance here for your reference. This AB distance. If P is perpendicular to AB, then only it will have a maximum moment. Please understand, this is a very important concept here. So for having a minimum value of P, it should have a maximum moment. The moment value at B should be maximum. When it will be possible? when P is perpendicular to AB. Now we got this information that P is perpendicular to AB. Now what we need to do? We need to calculate the angle actually. So this is one of the dimension. Right. Now how to calculate this one? Please understand. Very important part. First of all, let me just mark it here. This angle is 90 degree, right? This is horizontal, this is vertical. Let's suppose this angle is theta. This remaining angle will be 90 minus theta. Now this P is already perpendicular to AB. So this angle will be what? Theta only. I hope you are getting this point. Very important. This value is theta and this value is also theta. Now how to get this value theta? If I am able to calculate this theta, anyhow it is equals to this theta only. Right. So how you can calculate this part? So what we have discussed, this theta we have to calculate, and this theta is nothing but this theta only. So this theta, how I can calculate? Everyone please try to understand here. In front of theta, this would be perpendicular, this is base and this is hypotenuse. This base, how we can calculate? This is base, this is hypotenuse. Okay. Or let us don't write B, otherwise you will get confused here. Why I have written B? Because already B we have written there. Okay. So this dimension, this is total 300 mm radius, 50 mm step. So it would be 0.25 meter length. 0.25 meter length. This is already 0.3 meter radius. This theta we have to calculate. Perpendicular base. Base is 0.25, hypotenuse is 0.3. So what I am going to write here? Cos theta. Cos theta is nothing but base upon hypotenuse. Base is 0.25 divided by 0.3. So from here theta value we can easily calculate, and that theta is what the direction of P. This is the first part of the question. If I have solved theta value, and then we can easily get the value of P as well by taking the moment at B as 0. By taking the moment at B0. Now, why we can take moment at B0? Because we are writing moment B0 for a situation, for a moment when it is just about to roll. When it is just about to roll. Just about to roll means it is on the verge of rolling. It is not actually rolling. It will be on the verge of rolling, right? So theta value we can calculate, and if we have calculated theta, then what we need to do? Take the summation of moment at point B as 0. With this information, with this equation, we will get the P value as well. How we will write the moment at B? Because of P, let us write P minimum multiplied by how much distance? 0.3. Because P is perpendicular to AB distance, directly I can write. Okay, fine. P into 0.3. Another value, another moment will be created by the weight. This is P, another value will be weight. Now weight, okay, P is creating anti-clockwise and W, please understand this point, W will create clockwise. So clockwise and anti-clockwise moment I will consider to be equal for equilibrium condition. P is creating anti-clockwise, W is creating clockwise. 50 kg roller they have given. So 50 into 9.81, that is weight, multiplied by this distance, because line of action, the line of action of force, the weight force. Please understand, while writing moment, I have seen many times people will do mistakes there. This is the line of action of weight. From the line of action of weight, I want to calculate moment here. So this is the distance I need to calculate. Are you getting the point? This is the distance I want to use here for writing the moment. Okay. Now see everyone. So W, what we need to write? Multiplied by the distance. Which distance? This distance. That I can easily write 0.3 sin theta. 0.3 sin theta. And from here we will get the answer of P minimum. So this much basic calculation you can do it. So what was the concept here? To get the value of P, the minimum value of P, it should have a maximum moment at B. When it will have a maximum moment? when P is perpendicular to AB, AB is this distance, perpendicular to AB it should be there, the force P. And if it is perpendicular to it, we can calculate this theta, which is this theta only, right? And that theta calculation we have done, cos theta 0.25 divided by 0.3, and that theta I will use here to get the value of P minimum as well. I hope the solution is clear to everyone. You can just do the basic calculation. I will just mention the final answers here. Angle that is coming around is 33.56 degree. 33.56 degree, that is the angle theta, and the P minimum value is 271.15 Newton. That is what the answer we are having, right? Is that clear, everyone? So please understand, with every question you will be getting a concept. So please make a note of all those points. You have to make a note of all these points that we are writing here. Every question is equivalent to one important concept. No one knows like this kind of questions or this kind of concept will get used in the GATE examination. So please make a note of each and everything that we are discussing in the class, right? Now moving on to the next problem. Yes, this is also like one of the most important questions, and such kind of question already came in GATE examination, not in mechanical civil but in engineering science. Because in engineering science we have solid mechanics also. In that solid mechanics there is some part of mechanics is also there, right? Now in this question what actually they are asking, see, in this question they have given a plate, a rigid square ABCD plate is subjected to a planar forces. Planar forces they have mentioned, ABCD plate is there, P force and this P force. Planar forces they have mentioned at the corners. For this planar force system, the equivalent force couple system at corner A. So whatever force system is there, these are the three forces acting at corner B, C and D. They want the equivalent force system at corner A. At corner A they want the equivalent force couple system. Now how to solve such problems? There is a very important concept that everyone should understand. So before coming to this numerical, I will tell you one important concept here. For example, consider there is a body, right? On this body there is a force acting like this, P. I want to transfer this force to any other point. Let's suppose this was point A and this is point B. At point B I want to transfer force P. So when I have to transfer force, not only the force will come, apart from that there is a couple also acting. So how we will do this? See, so assume the same body I have taken. This is the force P at point A. At B what I will do? I will apply these two forces P having same magnitude as that of this force originally, applied parallel but in opposite directions. Like same magnitude of force we have applied like this. Now if I ask you, is there any change in the condition of a body? No. Why? This one and this one will get cancelled out. So this condition and this condition will not have any change. Correct. But one thing you will observe, this force P and this force P will form a couple. Same force, magnitude is same, parallel are there, both are parallel, there will be some distance, yes there is a distance, right? Acting opposite direction, yes, couple formation will be there. Now see, if I remove that couple value and I will show the couple magnitude directly here. So this is force P at point B. Couple direction would be clockwise, and that couple direction, couple moment value will be P into D, assuming the distance between them is distance D. So what we have understood here, if I have to transfer a force to another point, not only the force will come, apart from that a moment or the couple value will also be coming. Couple value means nothing but the moment only. So if I have to transfer this force, not only this P force is coming, apart from that couple value, that moment will also come here. This is a very important concept. So this force couple system This is what the force couple system, equivalent force couple system of this force. Equivalent of this force system is this force couple system, and equivalent of force couple system is this force. Vice versa, we can say. So this condition and this condition are equivalent. Okay, that condition and this condition are equivalent. Now, using this concept, we can solve this problem. Using this concept, we can easily solve this problem. Please understand, this is a very, very important concept. Single force system, and it is a force couple system. Equivalent of this force couple system is single force, and equivalent of this single force is force couple system. How we have got this point? Basically, we have transferred it here, but while transferring to point B, there is a couple or the moment value is also coming. Now, please remember, while transferring a force from point A to point B, direction we have maintained. As it is, we have transferred here. This P as it is, you have transferred. It is not like this, or like this. As it is, you have transfer. As it is, transfer means what? We have maintained the direction. The magnitude is same, direction is same, only point of application has changed. Only the point of application has changed, direction and magnitude are same. This is very important point. While transferring to point B, magnitude and direction are same, only point of application is different. Now, this concept, this particular problem, we can easily solve if you have understood this particular concept here. Now, everyone please try this particular problem and let me know about your answers. Everyone, fast. So, I will give you just 2 minutes for you, because this is like very easy problem. Okay. If you have not understood the concept, then it would be difficult for you. But if you have now understood the concept, now it is very easy. You have to identify system 1, 2, 3 and 4. Which system will give you the correct representation of equivalent force system at point A? Which system is correct here? Out of 4 options, which system is the correct representation of equivalent force system of this case at point A? At point A, equivalent force system we have to mention. So, which system is correct here? So, 4 options are available. Please let me know about your answers, everyone. And whatever you are getting answer, please mention in the chat box also. Okay. So, this session is very much helpful for your GATE examination. You will be getting a very good concept, very good problems, and that will build your confidence in the GATE examination. So, make a note of each and every concept that we are discussing in the session here. Last 50 seconds, everyone. Last 20 seconds. If you have any confusion in regarding this particular concept, please let me know. We'll discuss it again. Avinash said option D. Okay, we'll see. Last 1 second, and now time up. See, what I've told you, you just need to transfer the forces wherever they're asking. At point A, they're asking, na? Just transfer all the forces at point A. And while transferring forces, moment value will also come. Okay, so we'll follow that approach here. See, this P I've transferred to A, this P I've transferred to A, this P I've transferred to A, like this. All the forces I've transferred. Now, while transferring the forces, the moment value will also come. This P at point A will create a moment P into A. In which direction? Clockwise. This P at point A, how much moment it will have? P into A, again in clockwise direction. So, P into A plus P into A. That is the moment value at point A. Now, talking about the forces, now tell me, talking about the forces, this one cancel out. Right? This one and this one will get cancelled out. Only force will be the downward force. only force will be the downward force, but the moment value is 2Pa, not Pa, Avinash. That's why you got D answer. D answer would be correct, but problem is the moment value is wrong there. So correct option is option system B basically. System B, system second basically. System second is correct because 2Pa moment value and the net force value P in the downward direction. Option B basically, which is the system second, is correct answer. I hope, Avinash, is it clear to you? Like the option, why option second is correct here? Is it clear? Option B is the correct answer here. That is system number 2. So no need to confuse here. Simply transfer this force. This force transferred like this. This force transferred like this. This force transferred like this. Maintaining the magnitude and direction. This P cancel out. Remaining P in the downward direction. Okay, fine. This P and this P together at point A creates a moment Pa plus Pa, that is 2 into Pa. So that's why option B is correct answer here. Correct? Superb. Avinash, clear? Yes. Great. Now coming to the next part. Very important. So these are the questions that we have discussed from the equilibrium. Now we'll move to the truss analysis part. And in truss analysis, both in mechanical as well as civil, always you will find there is a question of zero force member. Always they are asking a question about the zero force member. Right. So we'll discuss the zero force member concept, and after that you need to tell me the answer for a zero force question. Okay. Just a small concept, 2 cases are there. If you have understood those 2 cases, then you can easily get the answer. Okay, and we'll see how fast you are able to get the answer. Fine. So zero force concept, there are 2 cases, like case number 1. In case number 1, what will happen? There is a joint formed by 2 members, member 1, member 2. Let's suppose they are having angle theta. Remember, joint formed by 2 members out of joint formed by 2 members and both are non-collinear. Okay. So what will happen? Force in member 1 and force in member 2 both are 0. What is the condition? Please remember the condition part. Condition is no load at joint and no support reaction at joint. No load at joint and no support reaction at joint. If this condition is satisfied, then only I can say force in member 1 and 2 0. So in case 1 we have discussed, if a joint formed by 2 non-collinear members, no load, no support reaction, then both the members are zero force member. That is the case first. Now writing the case number 2. Now let's suppose joint formed by 3 members, out of 3, 2 are collinear, third one is non-collinear, member 1, 2, 3. Again, please understand, joint is formed by 3 members, total 3, only 3 members should be there. So 3 members are formed, are there in the joint. Out of 3, 2 are collinear, 1 is non-collinear. So the third one, if the third one will become a zero force member. Again, condition is same. For this case number 2 also, this condition has to be satisfied. Again, for case 2 also, condition should be satisfied, then only you can say the third non-collinear member is zero force member. Out of 3, 2 should be collinear and the third one is zero force member, right? This is the only 2 cases you need to remember. That's it. These are the 2 cases that you need to remember. Apart from that, there is nothing extra required. With this 2 only, you can solve any problem of zero force member. And even if a question is not of a zero force member, still that zero force member concept is very much helpful in analyzing the truss problem. Because let's suppose there is a very big truss, complex truss they have given. But in that complex truss, there are few members which are zero force member. If you are able to identify those members, then the analysis become much simpler. Otherwise, you will always get confused. You might get fear also. Okay, big complex truss they have given, how to solve this one? It would be difficult. It seems to be difficult. No, it's not like that. In that big complex truss, you might see there are some zero force members. If those zero force members you have identified, then the whole analysis become very, very easy. Right? So always make sure it is not like only in zero force member question when they have asked calculate number of zero force member, then only it is required. No, in simple truss analysis problem where they are asking force in any member, there also this concept is very much helpful. Now let us see the problem. A very, very good problem they have asked. Okay, so let us everyone try. I will give you 3 minutes for this problem because this is really a very good problem, not that much easy. Okay, it is not that much easy question, but still if you try you will get the answer. I will give you 3 minutes for this problem. Everyone please try and let me know your answer in the chat box. Avinash, you can try and please mention your answer in the chat box. Please make sure that you have identified every members with regards to zero force member. Okay, sometimes what we will do, the some members we can easily identify and only those I will see, okay, these are the only zero force member and I will mark it. No, you have to analyze each and every member. There might be a possibility that some members are zero force member, but if you directly see the diagram, you are not able to figure out. For that, some analysis is required. So don't just see the diagram, try to use some equations of equilibrium and find out, is there any other zero force member or not? Try everyone first. It's like a zero force member. I don't know like why you are taking that much time. You can easily solve. Last 1 minute everyone. Anyone, if you have solved, please mention your answers. The zero force concept, it's like a very important topic, guys. Okay, I will give you one hint also. Calculate the reaction RC. Calculate the reaction RC, everyone. What is the reaction RC? What is the value of reaction RC? Anyone has tried? So do one thing. Tell me the reaction RC. Avinash, you are getting option B4. No. B is not correct answer. Okay, I'm giving you a hint here. The hint is calculate RC value. That is the hint. So I'm giving you a hint here. Please calculate the reaction RC. Then you will come to know that answer is not 4. It is more than 4. Calculate the value of RC. Okay. How you can calculate value of RC? Take the moment at A0. take the moment value at A0, you will get it. Do one thing, take the moment value about A0. So, okay, let us write it here itself. Summation of moment at A0. Okay, at A0 you will take, let us assume there is a reaction RC. So RC will have a moment about point A in the anti-clockwise. How much anti-clockwise? RC into 6. It is anti-clockwise. So minus this P clockwise, P into 3. So plus minus sign, it's up to you, like which sign convention you are following. Clockwise positive, anti-clockwise negative, or anti-clockwise positive and clockwise negative. It's up to you. So RC at A anti-clockwise, so I've used the minus sign, RC into 6. P into 3. This P, what will happen? This P, it will have a anti-clockwise moment. So it will be minus P into 3 equals to 0. Now P into 3 plus minus, what is the RC value then here? Answer is 0. RC value is coming as 0. D7. Yes, Avinash, absolutely. Option D is correct. 7 is the correct answer here. But you will get to know about that 7 answer if you have calculated RC value. If you have not calculated RC value, you will never get the 7 as answer. This RC value is 0. Now, using the cases that we have discussed here just now. Case 1, case 2. At point D, okay, the joint D, is there any support reaction? No. Is there any external load? No. No external load, no support reaction, and 2 non-collinear members, both will be 0 force member. Now, please look at joint C. At joint C, already CD is 0. The reaction, support reaction which is acting vertically upward is also 0. So, what will happen to CF? It will also become 0. Now, CF 0, CD 0, support reaction RC 0. This CB member will also be 0. So, 1, 2, 3, 4. 4 members we have identified. Now, please look at joint F also. Joint F. Sometimes whenever you are having confusion, please draw the diagram. Then it would be very easy for you to understand. Joint F free body diagram you should draw. Okay. Let me draw it here itself. Joint F. So this is joint F, right? This is one member, this is another member. I have not mentioned this member FC and FD because they are already 0. So this is the 2 members. Now, please understand. Very important part. FC is 0, right? Is there any member? Because this is an inclined one, it will have a horizontal and vertical components. Horizontal and vertical components it would have. But is there any vertical force or is there any vertical member to balance the vertical component of this inclined one? There is no one present here to balance the vertical component of this inclined member. Which inclined member I am talking about? FB. There is no one to balance it. So that inclined member has to be 0. So if it is 0, then obviously this horizontal, this another member will also be 0. Okay, so that's why sometimes directly looking at the diagram, you will not get an idea. Better always draw the free body diagram. So this is 0, this is 0. How many just now? We have counted 1, 2, 3, 4, 5, 6. 6 is not there. Where is the 7th one? Can you tell me the 7th 0 force member? Can you tell me the 7th 0 force member? Which member is the 7th 0 force member? I have mentioned only 6 0 force member. Where is the 7th 0 force member? What is your answer? Avinash, tell me. 7th 0 force member. So counting wise it is totally 6, right? Anyone? 6 we have identified, but answer is 7. So where is the 7th one? Yes, absolutely correct. Absolutely. FAB. AB, this member is also a 0 force member. Why it is 0 force member? See, please think about joint B. This is 0, this is 0. Now how many members are there? AB member is there, EB member is there, and external load is there. So external load will take care EB member because it is vertical. So EB will be equals to P. But who is going to balance the AB? No one. So that's why AB has to be 0. I hope you got the point. The 7 0 force member, right? So option D is the correct answer. Clear? So such kind of questions you can expect in the GATE examination as well, right? So both civil and mechanical engineering, this is a very, very important concept of 0 force member. Now we'll see the another problem. Yes, this is again a very, very important problem. We have to calculate a force in member HG. This HG member we have to calculate the force. Which method you will be using? Obviously method of section. In truss analysis, method of section is the one of the best method and one of the simplest and easiest method, and it will take very less time. So please try to calculate the force in member HG, and your time starts now. Do it fast everyone. HG. Use method of section. You have to use the method of section. For method of section, what is the first step? We will cut a truss with a section. And that section should pass through a member like HG, because that is what the unknown member. Our section should pass through HG member. So I can use a section which is going to cut the truss like this. So this is the hint. So this section we have to use. Either you can use the left part of a truss or right part of a truss. It's up to you, whichever in whichever part you are comfortable and which part you think it is easy to solve. So it's up to you only. So that section we can use. Two parts, left or right, it's up to you, whichever part you want to do the analysis. So please do it. Last 2 minutes you have. Do it fast and tell me your answers in the chat box. Try everyone this particular problem. I've already drawn the section which is used to cut the truss. You can use left or right. I would suggest better use the left part because less number of forces would be there. Left part you should analyze. Last 1 minute. Ten seconds left, everyone. Time up. Anyone got the answer? Anyone? So I think no one got the answer here. You might think it is a difficult one. See, truss problems, I'm telling you, you will always get full out of full if you have a like basic understanding of the force analysis part and some basic understanding of geometry as well. Right. Now, already I've cut a section here. That section we are going to use. But before that section, I need to calculate the support reaction Ra, this is Re. How to calculate the support reactions? See, equilibrium of entire truss we will be assuming. Equilibrium of entire truss. So summation of forces vertical equals to 0. That is the equation we will be using. So Ra plus Re equals to 2 plus 5 plus 5 plus 5. This 2 and 3 5 and one more 2 is there. Okay, 5 3 15, 15 and 4 19. So Ra plus Re 19 kilonewton. Let us take the moment, because I want to analyze the left part. So for me Ra value is important. So where I will take the moment? At E. I will take the moment at E as 0. Right. Now Ra multiplied by how much distance? This is 1, 2, 3, 4. 4 into 2, that is 8. That will have a clockwise moment. Okay. Apart from this, 2, 5, 5 and all 5 will have anti-clockwise moment. So we will write 2 into 8 plus 5 into 6, then 5 into 4, then 5 into 2. Obviously this 2 will not have any moment at point E because it is passing through that point itself. So how it can have a moment? So from here if you solve, it would be coming around 9.5 kilonewton, and obviously it would be there, and Re value will also be 9.5. And actually if you look at this particular given truss values, given truss and how the force they have mentioned, it is a case of symmetry. Symmetrical case it is there. That's why equal values you will be getting at Ra and Re, 9.5, 9.5. So it is a case of symmetry. But okay, even if you have not identified that symmetry, with the basic calculation you will get the answer, and hardly it would take like 20 seconds or 30 seconds to get this Ra and Re. But for us Ra is important. Now what I will do, I will draw this left part of a truss here. I will draw the left part of a truss. Okay. So better I will take the screenshot here so that it will be easy for you to understand also. Yes. So this is what we have. Now let us mention it here, very important. This is force in member Hg. This is force in member. What is this member? Bg. And this is force in member Bc. Right? Is it clear? How we have mentioned the left part of a given truss. We have used a section, cut a truss, and we have used the left part for analysis. Now, as it is a non-concurrent force system, we have only 3 options, like 3 equations of equilibrium. I hope you remember those equations just now we have written. These are the 3 equations of equilibrium I am having. Right. Now, obviously summation fx, if I use summation fx I cannot use because Bg and Bc, these are the 3 unknowns. With one equation 3 unknowns we cannot solve. Summation of forces vertical again we cannot use because Bg will be there, Hg will be there. Summation of moment is the only option I am having. Now for using summation of moment 0, I need to be clear about one fact, that I will select a point for writing this equation in such a way that other forces will not come in that equation. If it is coming, we cannot solve the equation, because one equation we can solve, with one equation only one unknown we can solve, right? That is very basic thing. So we will take a moment at B as 0, because at B only what will happen? Bg is also passing, Bc is also passing, so it will not have any moment. So moment at B I will be taking 0. Now very important point. See, this Hg will have this horizontal component. Let's suppose this angle is theta. So what is the horizontal component? FHG cos theta. Is it possible to calculate that theta value for us? Yes, that theta is nothing but this theta only. The same theta it would be there. Because if I consider this horizontal component, this is only is going to making a moment here, because FHG vertical component will pass through B only. It will not have any moment. So theta is what required here. Theta, for value of theta, I will again look at the complete truss. So in front of theta, that is perpendicular, that is base. Hi Saurabh. So we have this theta value. We can have directly this perpendicular, which is given as 3, and this is what the base at 4. So using tan theta, we will get the value of theta value. Tan theta perpendicular upon base, we will get the theta. That theta I can use here to get the FHG cos theta. So how the equation I am going to write? Okay. So first of all, tan theta I can write here. Perpendicular is what? 3, base that will be 4. Now please everyone see here. I am writing the moment about point B0. So the very first 2 kilonewton, this 2 kilonewton and this one, this 2 kilonewton and this FHG will be having a moment value at B only. There is no other force which will have a moment. BG and BC are passing through B only. How it can have a moment? Right. So we'll be writing this value first of all, 2 multiplied by the distance 2 only. It is having anti-clockwise moment. RA will have a clockwise moment. So RA value is 9.5 into 2. And what about HG? It is having anti-clockwise. So okay, we'll write minus FHG cos theta multiplied by how much distance? The total was 3, half will be 1.5 equals to 0. So this is the equation I am going to use, and from here I will get the answer of FHG. Right. So please first calculate the theta value, and that theta we will utilize. That theta value I am going to utilize in this equation to get the answer of FHG. So do it fast everyone. Okay. Theta value, that is coming around 36.87. Okay. Theta value is 36.87. You can please cross check the answers, 36.87 degree. So here how we will write? Okay, 9 into 5, that is 18 will be there. 18 minus this 4 divided by this cos theta, cos 36.87. Right. So FHG you will be getting from here. So take FHG. Okay, and this 1.5 is also there. You have to, because that distance multiplied by 1.5 also. Right, because that entire term goes to right side. So 18, 9.5 into 2, that is 19, sorry, not 18, it would be 19. 19 minus 4 we have to do. So 19 minus 4 divided by cos theta into 1.5. Cos theta value is 36.87 into 1.5. So from here you will be getting the answer of FHG. So make sure that you have done correct calculation, so you will be getting right answer. So anyone got the answer, so please let me know in the chat box if anyone is getting the right answer here. What is the answer here, everyone? I hope everyone has understood the theta value, how we have used this theta. Okay, we have calculated the support reactions first, and then FHG horizontal component will create a moment at B, not vertical component. So FHG cos theta multiplied by the distance 1.5. So the answer is approximately 12.5 kilonewton. So please everyone cross check this answer. 12.5 kilonewton is the correct answer for this particular question. Right everyone? Is it clear? Any confusion in any of the equations that we have used here? So you can ask. This is again a truss analysis questions. Is if you have understood the process, how we have to use method of section, how we will cut the truss, which equations we have to use. We have only 3 options. one by one try all three. Okay, if summation fx is not giving answer, summation fy is not giving answer, summation of moment will give the answer. But while using summation of moment 0, you have to be very careful and you have to be like very much clear about the point about which you have to write this equation. It means I will select a point in such a way that other unknown will not come into that equation. And when it will not come into that equation of moment, when they have a 0 moment about that point. So that's why intentionally I have selected B, because BG and BC moments are 0. Otherwise, if I select point A, there will be a moment of BG and that will create a problem for me. Otherwise, how I will get the answer? So with single equation, only one unknown you can solve. It is not possible to get the answer of more than one unknown in single equation. Is it clear, everyone? Great. Now moving on to the next numerical here, and that is from the friction. Equilibrium we have covered. Now we will discuss the problems from the friction chapter. Again, friction chapter very important for mechanical as well as civil. Right. Now a body of a dimension shown in figure, this kind of body it is there, and it is kept on an inclined plane having angle 30 degree. Okay, must be pushed up in the inclined plane. In the upward direction we are pushing it. What is the maximum value of height? Okay, what is the maximum value of height at which force P can be applied, they are asking, so that it will slide without tipping. It will slide without tipping, and coefficient of friction they have mentioned is 0.2. Now what is sliding without tipping? What is tipping case? This is very important to understand. So before solving this question, I will tell you one important concept of tipping here also, because already in civil engineering, if you see few years back, they have asked a very good MSQ question. In civil engineering, there was a very good MSQ question was asked related with the tipping in civil engineering. So that was a very good question. You can just refer the previous year booklet that you are having, and that you will get the solution, detailed solution you will be having. Now tipping case. So let us understand that tipping case here first. Let's suppose this is the block we are having. So consider this point that I am applying a force P here. Now obviously, if I am applying a force P, there will be a tendency of a body to rotate about this point. Obviously at this corner itself, it will have a tendency to rotate. Now it will rotate or not, that we have to understand. Under what condition it is not going to rotate, or what is the limiting condition when it will be just about to rotate. What is the limiting condition when it will be just about to rotate or just about to tip about this corner, that we need to understand. So that limiting condition means what? When the normal shift to this corner, friction, so like it will be tangential, but when normal shift to this corner, then we will call it as a limiting condition. This is a limiting condition of tipping. This is, we call it as limiting condition. And what will happen in this limiting condition? Body will be just about to tip. Body will be just about to tip. Just about to tip. Body will be just about to tip, or it will be on the verge of tipping. On the verge of tipping, like this. So that is what the limiting condition. Okay, when the normal shift to the corner. So whenever they are asking what is the minimum value of the force required, okay, minimum value of force required so that it will tip, we will take this limiting condition. Or always remember this point, when it is on the verge of tipping or just about to tip, normal shift to the corner, which corner? Where it is about to tip, that corner about which rotation is going to happen. So that limiting condition we have to remember. Okay, and you might ask, sir, ki why the normal is going to shift? A very basic understanding you should understand here, basic point. Normal in ideal condition, normal will be somewhere here close to middle point. Okay. What will happen here? Please see. Actually, if the force P was not there, normal will be actually acting at the center. As soon as the force is applied, normal shift towards the right side, or basically towards that corner point where it is about to tip. So let's suppose somewhere normal here is, and somewhere here the weight is going to act. This P and the friction force creates a clockwise couple formation. This P and this friction force creates a clockwise couple formation. That weight and normal will create anti-clockwise couple formation. So that anti-clockwise couple formation from W and N is trying to oppose the tipping, but this P and friction force couple is trying to induce the tipping effect. It is what the reason. P and F couple formation is the reason for the tipping, but W and N couple formation try to oppose that tipping. That's why in the limiting case, how far it can move? It can reach, it can go up to corner only. It cannot go up, like it cannot go beyond this point. Nah? That is what very basic common point. So what is the limiting condition? It can reach to this corner. Okay, it cannot go beyond this corner point, right? That's why the limiting condition means when the normal shift to the corner about which the tipping is going to take place. So I hope you have understood this point. This is very important. Okay. Now coming to this question part, everyone please understand. They are asking what the maximum value of height so that it will slide without tipping. Okay. Now first of all, so we need to understand the value of force for which sliding will take place. We need to understand the force value for which sliding is going to take place. So summation of forces along inclined plane. Along inclined plane, we will take it as 0. Summation of forces along inclined plane, we will take it as 0. Now along the inclined plane, so very important part is draw the free body diagram. Okay. Let us draw the free body diagram here, then we can easily solve this question. So the free body diagram of the block we will be drawing. Now see everyone, very important part. The weight component I am going to resolve W cos 30, W sin 30. Somewhere here the force P is acting. Normal will shift to this corner where the rotation or the tipping is going to happen, and this is what the friction force. Right, all the forces I have represented, that is what actually the free body diagram. Free body diagram of this particular block. Dimensions already it is clear, this is 50, this is 75. Now, as I have used summation of forces along inclined plane, so summation of forces along inclined plane I am going to write. So P minus friction force minus this W sin 30. So P value you will be having friction force plus W sin 30. So the friction force, how you will write? Mu into N, W sin 30. This is the value of P. Clear? This is the value of P. Now please understand, this is very, very important. Tipping case, the limiting condition, maximum value of height they are asking. Na? At what maximum height we can have so that tipping can be avoided and it can slide without tipping. Maximum height they are asking. So maximum height basically correspond to the situation of on the verge of tipping. That's why limiting condition I have assumed. Because as the height increases, the moment value increases here. As the height of P from this base increases, the moment value increases, and the tendency of rotation also increases with the moment value. That's why they are asking maximum height. So we will be considering the limiting case. Now what I will do, I will take the moment values directly here 0. Okay. So let us write here summation of moment. Let us write this point as A, this is B. at B as 0. So summation of moment at B I have taken 0 because equilibrium condition on the verge of moving, on the verge of tipping means what? Equilibrium condition only. It is not actually moving. It is just about to move. And when it is just about to move, that is a condition of equilibrium only. This is what very important point. So moment at B because of P. How much moment? P into H. Because the distance will be H. Clockwise moment, P into H. W sin 30, W cos 30 will have anti-clockwise moment. First of all, W cos 30 multiplied by half of this distance. That distance is 50, so 25. So I am writing in centimeters, so our answer of H will also be in centimeters. Then W sin 30. W sin 30. So half of this particular dimension, that is 75, 37.5. Okay. Now please understand here, H value I need to calculate. What is the P value? Mu into N. What is N value? Obviously N value will be equals to W cos 30 only. So W cos 30 plus what is W sin 30? W sin 30 will write as it is. So that is the value of P. This is the value of P multiplied by H. Right? Multiplied by H. Now, actually from the whole equation, W will get cancelled out. There is no need of mass also. Somewhat while solving question, you might confuse, sir, mass is not given, how to write W. W will actually cancel out from the last equation itself. No need to worry about the mass here or the W value. W cos 30 into 25 plus W sin 30 multiplied by 37.5. So this W is going to what? Cancel out from here. Coefficient of friction, what they have given? 0.2. If you put all those values here, you will be getting the answer of H directly. So that basic calculation, so like you can easily do it. The main concept of this particular problem was the tipping case, and that too the limiting condition. Limiting condition means when the body is just about to tip or on the verge of tipping. When I will understand limiting condition they are talking about, because they have mentioned maximum height. What is the maximum height when the tipping will not take place? So I will consider that height which will induce the tipping motion, or which will have a condition which will induce that condition when it is on the verge of tipping. That height will only called as the maximum height, because as soon as I have increased the height, moment value will be more and it will tip for sure. It will tip. So two type of questions they will be asking. What is the maximum height or what is the minimum value of force? Because when they are asking the maximum height, so P value will be what? Fixed. H is variable. But if they are asking the value of force, then height will be fixed. Then height will be fixed. So please understand, either they will ask maximum height or they will be asking minimum value of force P so that it can slide without tipping. Minimum value of force P so that it can slide without tipping. That is a second type of question can be asked from tipping. And tipping is very important both in mechanical as well as civil. Already in mechanical few years back it came, but in civil recently MSQ, a very good MSQ they have asked. And that is what very important. Please try to solve that PYQ also. So if you solve all those values here, the H value you will be getting here approximately as 60 centimeter as the answer. So you can cross check this answer as well. Approximately 60 centimeter you will be getting as the answer here. Okay. So please confirm everyone. Is it right? Everyone has done it. So 0.2 into W cos 30 plus W sin 30 it is there. Into H, W cos 30 into 25 and W sin 30 into 37.5. Correct? I hope this much is clear to everyone. Right? Now we'll move to next problem. Again, the friction is very important, so we will see one more problem here from the friction topic itself. So please make a note of each and every numerical. This is very, very important standard problems. Okay, It will build your confidence. Already you have solved the PYQ. Now it is a time to solve different variety of questions. If you just stick to the class notes and PYQ only, you will not be able to get a good score. If you really want to score a good marks, you have to solve variety of problems. When you are solving variety of problems, you will feel confident. Otherwise, any question comes which is not related with the PYQ, you will not be able to solve. As simple as that. You should understand this point. So, whatever upcoming Gate Booster series sessions we are having, you should attend all the sessions. Even if you are not able to attend, if you are watching in recordings, please make a note of all those important numericals that we are discussing. Tomorrow also we have a session for mechanical engineering, for thermodynamics and applied thermodynamics session. Do join that session as well, everyone. Okay. And parallelly, if you are enjoying the session, please share it and with your friends. You can like this session also. You can subscribe to our IMS Gate Academy YouTube channel, and please share this session to your friends as well who are preparing for the GATE examination. So they will also get benefited from the questions, the different set of questions that we are discussing in the session here. Not only this engineering mechanics, there are so many upcoming sessions we are having for the GATE examination. And many times you will feel, okay, whatever the GATE Booster series sessions questions you have solved, similar to that kind of question you might see in your GATE exam as well. So no one knows. So better prepare such type of problems as well, right? Now moving to the next problem, guys, and remember this is an MSQ. Okay, this is a MSQ problem. So this is a MSQ problem. How we have identified? Okay, they have mentioned is and are. Maybe one statement is correct, or maybe more than two statements are correct. So what is the question? Which of the following statement is correct for a given system as shown in figure? Coefficient of friction, static coefficient of friction, kinetic coefficient of friction. 1200 Newton force in the vertical direction downward, 150 in the horizontal towards left. And they're asking, there are four options they have mentioned. Basically, we have to see which options are correct. Block moving upward, block moving downward, friction force, two friction force they have mentioned, 390 or 279. Okay, fine. I need to analyze this particular system. To analyze the system, first of all, I need to understand where it is going to have a tendency of motion. Where is the tendency of motion? How we will identify? Okay, understand this point, very basic point. Obviously, this block will have a tendency to move in the inclined plane itself. It will try to move in the inclined plane. So I need to know where it is trying to move, upward or downward. Whether the body is trying to move in upward direction or downward direction, that we need to understand. How to decide? I need to calculate the net value of the force on the block along the inclined plane. And then only I can understand. If the net force is acting downward, it will move downward. If it is moving up, net force value is in the upward direction, it will move upward, right? So that is the first thing, because tendency of motion is required so that I can understand the direction of friction force. So that I can understand the direction of friction force. Clear, everyone? So let us mention the directions here. Okay. Better I will draw the free body diagram here, and then it would be easy for you to understand also. So this is the body we are having. Okay. One more thing, along the inclined plane, this is the direction. And this is what we can call it as a perpendicular to plane. Now, please everyone see, the forces how they have mentioned, 1200 vertical, 150 horizontal. Now that inclination is 30 degree. That inclination is 30 degree, right? So there is one force like this, horizontal, another force is like this. Now as I told you, can I say this angle is 30 degree and this angle is 30 degree, right? This one to like very basic, right? because inclination is 30 degree. So obviously this one also be 30 degree. Inclination of this inclined plane from the horizontal is 30 degree. So this one also be 30 degree. Okay, fine. This is clear. Okay. And one more thing. This is perpendicular direction and this is perpendicular to inclined plane. Perpendicular to the inclined plane and vertical direction always have theta, that is the inclination angle. So this is theta value, that is 30 degree. So this one also be 30 degree. Like that we have identified the angles also. Correct? Now, this was 150 Newton and this was 1200 Newton. Now let us take the components along the inclined plane. So this is 150 cos 30. This will be 1200 cos 30, but this one is 1200 sin 30, and its vertical component here again perpendicular to the inclined plane, plus I should write 150 sin 30. Okay, like this. So we have mentioned the forces as well. Fine. Now where will be the tendency of motion? Obviously I can say 1200 sin 30 is 600 and that value will be more than 150 cos 30. So it has a tendency to move in the downward direction. So we can write here as 1200 sin 30 is greater than 150 cos 30. So block will have a tendency to move downward. Tendency to move downward. So block will have tendency to move downward because 1200 sin 30 is downward, greater compared to 150 cos 30. Now the friction force. Let us mention the friction force values. This is the friction force that will act upward, and that is what we have as normal force. Fine. Clear? Friction force upward because the tendency was in the downward direction. So friction force will oppose that tendency and the normal force is there. Is it clear everyone? Correct? Now, what I will do, I will calculate the value of friction force required so that it will remain in static condition. I am assuming, okay, because if you see the option they are saying moving upward or downward or the friction force, what will happen? It will remain stationary or it will move upward or downward, I don't know. I will assume body to be under equilibrium condition. Body to be under equilibrium condition, and for having that equilibrium condition, what is the friction force value required? What is the friction force value required so that the body will be under equilibrium condition? So required value of friction force I will calculate. So I am writing here assuming equilibrium. Assuming equilibrium condition. Please see. Summation of forces along inclined plane. So along the inclined plane we have 1200 sin 30 minus 150 cos 30 minus friction force equals to 0. So from here friction force value I will calculate. From here I will calculate the friction force value. So please do everyone calculate these values. So if you calculate these values, it will come around 1200 sin 30, 150 cos 30. Right. So please everyone calculate the values. It is coming around 470.096 Newton. So you can just cross check the data and the information values also. 470.096 is the friction force value coming. This is the friction force required. Now obviously everyone knows the maximum limit of friction force. the maximum value of friction force is mu s into n. That is the maximum limit. Above that, it cannot offer friction force. Maximum possible friction force. Maximum value of friction force possible. Maximum value of friction force is nothing but mu s into n. What is n? N is the 1200 cos 30 plus 150 sin 30. That is. So summation of forces perpendicular to the inclined plane, you will take it 0. N value will be equals to this summation only. Okay. So that we can write it here itself. Okay. So that mu s value, what is the mu s value? In the question they have given us 0.35 into n. N value is 1200 cos 30 plus 150 sin 30. So you will get the answer of friction force. Maximum value of friction force you will be getting here. Is it clear, everyone? Maximum value of friction force you will be getting like this. Okay. So how we got the value of n? Let us write it here itself. Summation of forces perpendicular to inclined plane. Right. So that n equals to 1200 cos 30 plus 150 sin 30. Okay, that value we have substituted. Maximum value of friction force you will be getting. So if you calculate the maximum value of friction force, okay, so just calculate it, this 1200 into cos 30 plus we have 150 into sin 30. Okay, that is what the value of n, then multiplied by 0.35. It is 389.98. You can consider it as approximately 390 Newton. Now, while calculating this value, you might see option 390, option C is correct. You might think option C is correct because friction force 390 Newton and we also got the 390 value. But that is not correct. Why it is not correct? Please understand, this is very important. Friction force required for having equilibrium condition is 470. What is the maximum possible value of friction force? 389 or 390 Newton. As the maximum value of friction force is less compared to the actual value, how it can remain under equilibrium condition? Will it be under equilibrium condition? Tell me, yes or no? It will be never under equilibrium condition. Avinash saying option B and D. Absolutely correct. Absolutely, Avinash, great. Because as the friction force, the maximum value of friction force is less compared to the required value, it will be under dynamic condition. Where it will move? Obviously in the downward direction. Dynamic condition it would be there. And in dynamic condition, friction force, how you will calculate? Using kinetic coefficient of friction, not using static coefficient of friction. So one more option they can have, whether the body is under stationary condition or not. Okay. So let us write that point here. Okay. Just write one more point, very important. As required value of friction force is more than the maximum possible value of friction force. Maximum possible value of friction force. Clear? So as required value of friction force is more than the maximum possible friction force, so body is under dynamic condition. It cannot be under equilibrium condition. It is under dynamic condition. And for dynamic condition, friction force, we will call it as dynamic friction force, which is mu k into n, which is called as mu k into n. Mu k value in the question is given as 0.25 into n value. N we have already written 1200 cos 30 plus 150 sin 30. Correct? Like this we have to write. So if you just calculate this one, 1200 into cos 30, then we have 150 into sin 30 into 0.25 finally. So 278 it is coming, approximately 278.55 Newton. So this is the actual friction force which is acting in this particular condition. So if you look at the options here, so body is moving upward or downward, it is moving downward. Friction force is 390 Newton, no, friction is 279. Why the friction is 390 Newton? Why it is not 390 Newton? Because it is maximum value of friction force, it is not the actual value. Actual value, how we will get it? First we have understood it is under dynamic condition. Once it is under dynamic condition, friction force calculated by mu k into n, not mu s into n. I hope this part is also clear to everyone. This is like a very good question they have mentioned here. So such kind of MSQ you can expect in your GATE examinations as well. Such kind of MSQs are very, very important in the GATE examination. And you will be able to solve only if your fundamentals and if your basics are clear. Otherwise you will confuse in this case whether it will move or downward. First understand the motion here. The body will always move along this direction. So in this direction, what is the value of net force? That net force value we have to understand, whether it is upward along inclined or downward along inclined. Accordingly, I will understand tendency of motion. Tendency of motion is understood. After that, friction force direction we can easily mention, because friction force will always oppose the tendency of motion. Clear? Right, now coming to the next problem, that is from the centroid and moment of inertia part, and that question they are asking, find the area moment of inertia of a remaining section about XX. So this is XX section, square hole is punched out of the circular lamina. So circular section is there, from that this square hole is there. So we have to calculate for this section. We have to calculate for this particular remaining section. For remaining section we have to calculate. How to calculate the area moment of inertia? Very basic. Okay, first of all, can I say it is symmetrical about XX? Yes, it is symmetrical about XX. Right. So what I will do, calculate the area moment of inertia of the whole circular section about XX minus area moment of inertia of this square section about the XX. Then we will subtract. You can subtract and add those moment of inertia values if they are calculated about the same axis. If they are calculated about the same axis only, then only you can add and subtract. Otherwise you cannot add and subtract area moment of inertia. It has to be calculated about the same axis, right? Now how we will do this problem? See, let us take the diagram in the next page also. Right, now please everyone see here how we will solve this one. So about XX, so what I will be doing first, area moment of inertia of circle minus area moment of inertia of a square section. Correct? Area moment of inertia of a circle minus area moment of inertia of square, because again circle about XX only. about xx. So moment of inertia about xx equals to circle moment of inertia pi by 64 d to the power 4. What is d? Radius they have given 8, so diameter will be 16 to the power 4 minus. Okay, how to calculate area moment of inertia of the square? About its diagonal, what I can do, I can calculate the area moment of inertia of this triangle, and then multiply by twice. So area moment of inertia of a triangle about its base and then multiply by 2. I will be getting the total area moment of inertia of a square about xx direction. About xx axis I will be getting very easily. So twice, because I am writing for a triangle about the base. Now for a triangle BH cube, B is what? 8 here, H, so that will be 4. BH cube by, that H is nothing but 4 cube by 36. And actually we have to use the parallel axis theorem, because BH cube by 36 is about its centroidal axis. Centroidal axis is h by 3 distance from the base. So we have to use parallel axis theorem. Right? So if I have to use parallel axis theorem, so area of triangle will be half base into height. 8 into 4, that is area, into height 4 by 3, h by 3 from base, na? So 4 by 3 square, like this. So using parallel axis theorem, we have written this relation. Now you can easily solve. So using parallel axis theorem, correct, using parallel axis theorem you can get this answer. So just you need to put the values, you can calculate, you will get the answer. So please let me know about your answer. Avinash, what will be the answer here? Tell me. The basic calculations you can do, na? So tell me your answer. About xx axis, what will be the answer here after solving this one? What will be the answer here? This is what basic mathematics, no? So this calculation you can perform very easily. I don't think so that will be a difficult task for you. Okay, you have to be habitual of using the virtual calculator. If you are using the physical calculator, then it would be very difficult for you in the GATE examination. Right now also you should use the virtual calculator. Wherever you are practicing, whenever you are practicing, use the virtual calculator always. Because there in virtual calculator we have to put the values, right? Multiple times we have to click and those things. There is a challenge, I know. But once you are using it for a longer period of time, you will become habitual of it. And you will never face a problem. And don't write the entire equation in the calculator itself. Okay, don't try to write the entire equation. Like let's suppose this I have to calculate. Don't write this part, then minus this part, plus this part, because chances of mistakes will be there. Because even if one of the bracket you have missed or something happened here, definitely whole answer will get wrong. Even if you know the concept, everything you know about the question, everything, but still you are getting wrong answer. Better thing is what? Calculate this part separately, calculate this part separately, calculate this part separately, and then solve. Don't take unnecessary risk of getting wrong answer during the calculation using virtual calculator. It's my sincere, like please understand, it's my advice to everyone. Do the calculation separately. Don't write entire equation in the virtual calculator. Better you will take 10-20 seconds more in solving question, but at least you should not be getting wrong answer. For those questions in which you know everything and you will get right answer, but because of silly calculation mistakes and the mistakes that you have done using virtual calculator, you are getting wrong answer. The whole effort that you have put in to solve this question will go waste. So that should not happen, right? So please understand, it's my advice to everyone, use calculator in part wise. Calculate this part and this part separately. Then add all those things, right? So answer that is coming is around 3131.6. Later on you can cross check and confirm me your answers as well, right? Done everyone? So that was the area for triangle into distance square, that is 4/3, because from centroidal axis the base distance is h/3. Correct, fine. Now we'll start the dynamics part everyone. This dynamics is like very important. Okay. Now before starting the dynamics part, some of the things which is important for your vibration part in civil engineering I want to discuss here. Okay, like in vibration part, what you need to understand, for a spring mass system, whether this kind of spring mass system or if it is like this also, or if it is like this, in all three cases natural frequency formula is under root k by m, right? What is k? K is the equivalent stiffness and k value has to be in Newton per meter. Mass should be in kg. This unit please take care, otherwise sometimes they will give the value of k in kilonewton per meter, Newton per centimeter, Newton per mm, like that. You have to convert it back into SI unit, that is Newton per meter. That is omega n. Unit is radian per second. Another way of writing natural frequency is in hertz, which is omega n by 2 pi. And the unit is hertz. What do you mean by this hertz? It is the number of cycles per unit time. Number of cycles of oscillation or vibration. How many cycle of vibration and oscillation is happening in per unit time? That is what Fn will tell you. And there is one more parameter, that is time period, which is 1 upon Fn. And the unit is second. So it will tell how much time will be taken to complete one cycle. How much time is taken to complete one cycle. So remember these things. Time taken to complete one cycle. Right. These are the formulas that you need to remember. Apart from that, series combination of your springs. So of spring, how you will write the equivalent stiffness. So for example, I will draw the diagram also here. So 1 upon K equivalent stiffness right. Then we have parallel combination of spring. K1, K2. In this case, equivalent stiffness will be nothing but the addition of the stiffness itself. So these are the like basic details, at least you should know. Then you can easily solve the vibration problems very easily. So what happens in parallel combination? The deflection value is same for all the springs. In series case, deflection of all individual springs will get added and the total deflection will be the deflection of the system mass. In parallel combination, deflection is same. How to identify whether it is series or parallel? if the deflection is same for all the springs, it is a parallel combination case. Very simple, right? Now coming to the dynamics part, guys. Dynamics part that we have to discuss, very very important. So let us write it here itself, the dynamics. So there are few formulas or the relations that we'll be having, and that we will write it in a very short concise manner. And if you know those formulas, if you have idea about those formulas, you can solve any problem of mechanics. Very limited formulas we are having, very very limited formulas, right? For example, dynamics has two parts, kinematics and the second is kinetics. First I will talk about kinematics part. In kinematics we have three types of motion, because in kinematics we will talk about motion only: translation, rotation, and then T plus R types of motion, correct? In translation we have further two types of translation, like rectilinear and curvilinear, right? We'll start writing some important relations of rectilinear, curvilinear, and then rotation, and then kinetics. All relations we'll write together. See, if I talk about rectilinear translation case, rectilinear translation case, please understand. The rectilinear translation means motion along a straight line. So there are three fundamental equations that we need to remember. V equals to ds by dt velocity, dv by dt acceleration, a dv equals to v dv. These are the three fundamental equations. Fundamental equation of motion for rectilinear translation case. Simple. Now, if I talk about the curvilinear translation, two important acceleration components we need to know. Okay, curvilinear, simple curvilinear translation case. Tangential component of acceleration formula is R alpha, meter per second square. And another one is normal component of acceleration r omega square, or we can write v square by r. That is tangential component of acceleration. Normal component of acceleration. Tangential, I am not writing that point, please you can note it down in your notebook also. Tangential component of acceleration represents the rate of change of magnitude of velocity. Rate of change of magnitude of velocity, and normal component of acceleration represents rate of change of direction of velocity. So whenever direction changes, normal component of acceleration always exists. Tangential component of acceleration will be there whenever change in the magnitude. Magnitude changing, tangential will come. If direction changing, normal will come. So this two component of acceleration you should always remember, right? So for example, a particle or any body is having this curved path. Tangent direction will be there. In this direction, tangential velocity will be there, and as well as tangential acceleration. This is the center of curvature. Towards the center of curvature, we have the normal acceleration direction, that is fixed. Towards the center of curvature, normal acceleration direction is there always. But if I talk about tangential component of acceleration, it will be along the tangential velocity only if magnitude is increasing. if magnitude is decreasing, if magnitude of tangential velocity is decreasing, in that case tangential acceleration will be opposite to the tangential velocity. That's it. Is it clear, everyone? The very basic point, correct? Okay, fine. So rectilinear, curvilinear case we have discussed. Now coming to the rotation part, there's some fundamental equations that we need to remember for rotation part also. Similar to translation case, but how we will write? See, omega equals to d theta by dt, unit radian per second. Angular acceleration, d omega by dt, alpha d theta equals to omega d omega. So this is called as fundamental equation. Fundamental equations for the rotation case. So these are the fundamental equations. Now coming to the next part, translation plus rotation, where both translation and rotation will be there, that is called as general plane motion. Example, rolling motion. Rolling motion, some important detail I want to highlight here. Because we'll solve a very important numerical from rolling also, so some basic details you should always remember. Right, so see, it is under rotation as well as translation. So rolling case, in pure rolling case, velocity of center of mass is r omega and acceleration of center of mass is r alpha. Velocity of center of mass is r omega, acceleration value is r alpha. Clear? This is the information we should remember for pure rolling case, or we can say rolling without any slipping, that is actually called as pure rolling. Right, this data. Now coming to the next part. Okay, before going to that numerical, kinetics formulas, very very important, and you should remember entire kinetics is based on Newton's second law. So first of all, Newton's second law only, and remember here we will write formulas for linear motion case, and on the next side of it we will write rotation case. Okay, first linear case and then rotation case. Linear case, please see. The force, okay, or you can directly write net value of force equals to mass into acceleration. Acceleration will be in the direction of net force. Acceleration value will be in the direction of net force, and that acceleration belongs to center of mass. In this case, torque value equals to mass moment of inertia into alpha. Mass moment of inertia and torque should be taken about the same point. Keep in mind that torque and mass moment of inertia are taken about the same point. This is very important point. Many times the mistake will be done here itself. Wherever we are writing torque, about the same point I should write mass moment of inertia in the equation. Okay. So that is the first relation. Second, work energy principle. Work done in linear case, how you will write net force into displacement equals to change in kinetic energy. Obviously, kinetic energy means linear kinetic energy, that will be half mv final square minus half mv m square, like this. So that's how we will write work done in case of linear motion. Now in this case, net torque value or net moment. Okay, sometimes you can use moment and torque also, there is no problem in that. Net torque multiplied by theta value equals to change in kinetic energy, but kinetic energy means rotational kinetic energy, half I mass moment of inertia omega final square minus half I omega initial square. Clear? Then next thing that we have is linear impulse momentum equation and angular impulse momentum equation. Linear impulse is net force value for small time period dt 0 to t, that is linear impulse, equals to change in momentum mv final minus mv initial. mv final minus mv initial. Now here 0 to t net value of the torque or the moment. So let us keep it torque only, dt. Okay, don't be confused with t and t. Okay, so better write moment here because you might get confused also. I am writing m instead of torque here, dt, change in angular momentum. Correct. So this value, what is this value? This is the linear impulse, that is angular impulse. Okay, this is called linear impulse. And this is called as angular impulse. Correct. These are the formulas that we need to keep in mind. Okay. So these formulas we have written here. Entire kinetics of particle and rigid body has like this much formulas only. This much formula. Okay. And one more important formula regarding angular momentum you should write. Maximum time people are confused which formula we have to write for angular momentum. Sometimes you are writing I omega, sometimes you are writing r cross mv. Actually angular momentum is nothing but moment of momentum only, or I can use I omega. So r cross mv I am using for the particle. Okay, and for rigid body I will be using this formula. So both the formulas are correct. Actually I omega came for r cross mv only. From r cross mv only I omega came. The complete derivation part, if you see, for I omega it came from r cross mv only. So cross product of r and mv. R is position vector, mv is what? Linear momentum. So angular momentum is also called as moment of momentum. Moment of momentum. Is it clear, everyone? Done? Now coming to the numericals part. This is one of the best problem you can see in the dynamics, and you can expect such kind of questions will come in your GATE examination as well. Such kind of questions will definitely come in your examination as well. So please everyone try this one, and I will give you the 3 minutes for this particular question. Everyone should try this particular problem. Do it everyone fast. Do it everyone fast. Last 40 seconds you have. This is really a very good problem, right? This kind of question you can expect in the GATE examination as well. Definitely, this is like one of the most important question of the entire session, I would say. Because it has a concept of rolling, kinematics also, kinetics also. So many concepts are involved in this particular problem. Time up. Okay. See, we will look at the first of all the motion here. Please, everyone. Okay. Better we'll draw it here and then we'll write. So, what is the information given? Omega naught in the anticlockwise. Now, anticlockwise sense of rotation is there. So, tell me one thing. This point will try to move towards right direction. So, the friction force will apply. In which direction friction force will apply? Friction force will be applied in this direction. And that will be our normal reaction. That will be the weight, which is mg. Clear? That is the free body diagram. Okay. One by one we'll apply equations of motion. Because it is a case of rollings, translation and rotations, both will be happening simultaneously. For translation case, summation of force equals to mass into acceleration. For rotation case, summation of moment or torque equals to I alpha. That's how we will apply the equation of motion. So what I told you, you have to understand, you have to visualize the motion, then associated with that particular motion, equations we have to write. Equations of motion. So for translation, equation is summation of force equals to mass into acceleration. Okay. Only horizontal force is friction force. Mass into acceleration. Friction force will be mu into normal force, that is mg actually. So this mass gets cancelled out. So acceleration value equals to mu g. This x direction acceleration is mu g. Clear? Fine. Now another equation that we have is torque equation. Summation of moment or torque we can write equals to I alpha. Moment, the torque value we will be writing about the center. So about the center, this friction force multiplied by radius. Please understand, this friction force at the center, we have to multiply it with radius not to get the torque value or the moment value. So that friction force multiplied by radius r, mass moment of inertia about center, mr square by 2 multiplied by alpha. Now please understand what I have told you about this equation. Wherever you are writing torque, the point about which you are writing torque, about the same point you have to write down the mass moment of inertia as well, right? So this r will get cancelled out. So alpha value, okay. So friction force is mu mg because normal is mg value. So mr square by 2 into alpha. This m gets cancelled out, this r gets cancelled out. So alpha value will be 2 mu g by r. Okay. 2 multiplied by mu g is there divided by r. That is what angular acceleration relation we have solved. Fine. Summation of forces along mass, summation of moment equals to I alpha. We have applied translation and rotation, both the cases equations we have applied. Fine. Now see, you have to read very important point here. Determine the time before it start roll without slipping. That is rolling motion, pure rolling motion. When it will happen? When center point will have r omega velocity. Only at that particular moment only it will have the rolling motion, right? So assuming the instant at time t this particular disk start rolling. Disk starts rolling. At time t, disk starts rolling. Fine. So we have written this point. Okay, understood. So velocity of center of mass equals to r omega. That is the formula we have. That is the formula we are having now. Velocity of center of mass equals to r omega. Now what we will be doing? We will apply the equation of motion. We already have an acceleration a. We already have an acceleration a. So v equals to v naught plus acceleration at. According to the given situation, is there any initial translation velocity is there? According to the information given in the question, is there any initial linear velocity they have given? No. What will be the value of v naught? It would be 0. What is v after time t? It equals to r omega plus acceleration. What is acceleration? Mu g. Acceleration value is what? Mu g. So that mu g value is there. That mu g value, it will come here. So that time t equals to r omega by mu g. But omega is the value after time t when it has achieved the rolling motion. But I want my answer in terms of omega naught. I want my answer in terms of omega naught. So what I will be doing? What I will do? I will use omega relation. I will use omega relation. How? See, everyone, please carefully understand this point. So t equals to r omega. Omega is the value after time t when it has started rolling motion. Got it? This point, everyone. So omega value at time t when this start rolling. Now omega equals to omega naught plus alpha into time t. Omega value already we have written. Omega naught means initial angular velocity. According to the question, initial angular velocity, they have given omega naught. According to the question, initial angular velocity is omega naught, they have already given. So keep it omega naught only plus alpha. Alpha we have calculated, yes, 2 mu into g divided by r into time t. Now the problem here is many people will forget that negative sign will come, and that's how the mistake will happen. Why the minus sign will come? Please understand. Omega, where it is anti-clockwise, where is the alpha value? Clockwise, because alpha will be in the direction of torque applied. Alpha will be acting in the direction of torque applied. Torque is applied by friction force. In which direction? Clockwise. So alpha will be in which direction? Alpha, clockwise, which is opposite to the omega naught. So that's why alpha we have to use negative sign here. Are you able to understand this point? Yes or no? Alpha we have to use negative sign because the torque applied is in clockwise. So torque in clockwise, so alpha will be in clockwise. As alpha is in clockwise, omega angular velocity that we are having is in anti-clockwise. So accordingly, negative sign we have to use for alpha. So this is a very important point. Otherwise, if you use positive sign here itself, you will be getting wrong answer. Okay. So see, this is there 2 mu g by r. Now time we have calculated, na, that time value I will substitute here. Time value was r omega by mu g. So you will find that mu will get cancelled out, g will get cancelled out, r and r also get cancelled out. So omega equals to omega naught minus 2 omega. So omega value will be equals to omega naught by 3. This is what the relation also they are asking. And this is very, very important. You might see question definitely coming from this one. What is the angular velocity when it start rolling? That is omega naught by 3. With this omega value, it will start rolling. That answer is omega naught by 3. I hope this point is clear, everyone. Omega equals to omega naught. Now I can get the value of time also in terms of omega naught. So t already we have solved as r omega by mu g. So this instead of instead of omega, we'll write omega naught by 3. This is the time. I'm telling you, such kind of question you can expect in your gate examination. So please make a note of all these important numericals. Okay. So this is what we'll get as an answer here. It's very, very important numerical. I'm telling you, this is like a very important numerical. Right. So understood how we have solved translation equation of motion, rotation equation of motion. Some data we got it from here, alpha, here linear acceleration we got it. Then at time t disk start rolling, that I have assumed. So what will happen during the rolling motion, pure rolling motion? Velocity equals to r omega. Linear velocity is v equals to v naught plus at. Okay, so v value r omega, v naught 0, acceleration value mu g into t. So t equals to r omega by mu g. This is the time we got, but that r is in terms of omega, that we don't know, right? So what we have done, we have taken omega equation, that which is omega naught plus alpha t. But here important point is we have to keep alpha is negative, because alpha direction and omega directions are opposite. That's why alpha we have to keep it negative. And accordingly we got the relation of omega. The omega is that omega where the pure rolling motion exists. Omega naught was the initial angular velocity with which the disk has been projected in the plane. So omega is the velocity when the disk started rolling, pure rolling motion. So omega naught by 3. This is also very important part of the question. And then finally time in terms of omega naught. I hope the whole question, the whole concept of pure rolling is clear in this particular problem, right? Clear everyone? So please make a note of this one. This is really a very important problem that we have discussed just now. Okay. Now we'll move to the next one also. Next question. This one. Okay. I will give you the 3 minutes for this particular question. Start solving everyone. They are asking the acceleration of the center of mass. Acceleration of the center of mass when there will be a pure rolling motion. That is without any slipping. Rolling happening without slipping is nothing but the pure rolling motion. Do it fast everyone, last 2 minutes you are having. Do it fast everyone. What will be the acceleration value of the center of mass? Apply the torque equation, directly you will get the answer. Directly apply the torque equation, guys. Last 30 seconds. 10 seconds left. And time's up. See, let us consider the contact point as A. Contact point A, we will take it here. So if I write the moment equation or the torque equation about A, right, about A we have to write. So what will be the torque? P multiplied by the diameter, that is twice of R. Mass moment of inertia about point A. So obviously we know that about the center it is mr square by 2. For writing about point A, parallel axis theorem we have to use. So we will write mr square by 2 plus mr square into alpha. So from here alpha answer we will be getting. From here alpha answer will be getting. So P into 2R, this will be 3 mr square by 2 into alpha. So alpha value will be 2 into 2, that is RR first of all gets cancelled out from here. So 4P by 3 mr. That is what we have as angular acceleration. Now what we will do with angular acceleration, because we know that during the rolling motion without slipping, center of mass will have an acceleration equals to R alpha. That's why alpha we have solved first. Okay, because we know that acceleration of center of mass for rolling without slipping case is R alpha. Just now we have calculated alpha also. So that alpha value we will substitute here. Alpha value, alpha means what? 4P, that we have calculated. 4P by 3 mr. Right, so the final answer will be 4P by 3m. This is what we will get as an answer here. 4P by 3m. Okay, RR will get cancelled out. So 4P by 3m is the linear acceleration of the center of mass, meter per second square. So center of mass acceleration it is there. Is that clear everyone? Basic problem, right? Understood. So torque equation, how we have to apply, that point is very, very important here. Now next one. This is also a very, very important question, guys. Such kind of questions definitely you will expect in the GATE examination. I'm telling you, such kind of questions are like very important in the upcoming GATE examination. So don't miss any single question. Make a note of every questions that we are discussing in the GATE Booster series. You might see some kind of questions related to this one in your GATE examination as well. Okay. Now, a uniform beam having a weight W, if it is originally under rest condition, supported by A and B, right? So at A and B, what are there? The cables are there. Determine the tension in cable A. In cable A, tension we have to calculate. Okay, when cable B suddenly falls. So, or we can say it has been cut or it has been failed. What is the tension at A? Tension for cable A, assuming beam of cylinder rod. Now see, first of all the free body diagram. I'm telling you, all engineering mechanics problem will become easy for you if you are drawing a correct free body diagram and you have understood what kind of forces are acting on the free body diagram, and accordingly write equations of motions you have used. You will easily get the answer. Okay. Now see, at point A, TA tension will be there. This is the center point where the weight will be acting. Okay, distance from this point A, and let's suppose this is the center point C, will be L by 4, because L by 4 distance is also there from point A. So from center to extreme end it would be L by 4 plus L by 4, that is L by 2, correct. So center point L by 4 is there, tension TA. This is what the free body diagram. why tension TB will not be there? Obviously because it has been cut, so why the tension will be there after that? Correct. Now apply equation of motion here. First of all, summation of forces vertical equals to mass into acceleration. Vertical, obviously. W minus tension equals to mass into acceleration. So this is the first equation we have. Correct? This is first equation. Now second equation. As it is connected here and the weight is acting, so it will have a torque at point A. It will start rotating about point A also. So torque equation we can write. About which point we are writing? About A. So about A, what is the torque? W into L by 4. Mass moment of inertia ml square by 12. Parallel axis theorem I need to use because I want to calculate mass moment of inertia about point A. ml square by 12 plus ml by 4 whole square. Into alpha. From here alpha value you will be getting. Yes or no? Correct? Any doubt, any confusion in this problem, please let me know, everyone, guys. If there is any doubt or any confusion here, please let me know. So from here alpha value you will be getting. Okay. So W, how you will write W? mg, right? L by 4. L by 4, L square by 4 square, that is 16. 12 or 16 LCM if I take, it would be 48, right? And 4 I need to multiply here, 3 I need to multiply here. So 7 by 48 ml square into alpha. M and M will get cancelled out. So alpha value you will be getting, okay, and this one also 48 it is there now. So you can easily calculate, it would be 112. Okay, so alpha value you will be getting as 12 by 7 G by L. That is the alpha value. Please everyone check this answer. So alpha value will be 12 by 7, right, G by L, because that L is already cancelled out from here. So G by L, that is alpha value. Now one more thing, as it is under rotation case, please understand, very important point. This is the weight acting here, this is the tension, it will try to rotate like this. Okay, this is the rod, as the weight acting here, it will try to rotate like this. What is the acceleration? R alpha. Rotation case, tangential acceleration will be R alpha. So this acceleration value we can solve here. R alpha. Now what is R? From this is the point of rotation, weight force is acting here. What is R here? L by 4 multiplied by alpha. Alpha value is 12 by 7 G by L. L cancel out. 12 by 7. So it would be 3 by 7 we should write. 3 by 7 G. This is what the acceleration we have solved. 3 by 7 G. Right. Now this value of acceleration we will substitute in equation 1. So from equation 1, we will write W minus tension T equals to mass into acceleration, which is 3G by 7. Now W minus tension T, M into G is nothing but W only. So W minus tension T equals to W 3 by 7. So tension equals to W minus 3 by 7 W. So that will be equals to 4 W by 7. That is what the answer here. This is the value of the tension here. 4 W by 7. That is the answer here. I hope the solution is clear to everyone. This is like a very important question. Again, This is the second most important question, I would say, of the entire session. Although all questions are important, but this is second most important question. If you ask in the priority wise, this is the second most important question here. So answer here is 4 by 7 W. Tension value is 4 by 7 W. So again I am telling these questions are not tough if you have understood the motion. So as soon as this has been cut, what will happen to this rod or beam? It will rotate. What are the forces? Tension T upward, W downward direction. Linear equation I will write. Summation of forces vertical equals to mass into acceleration. Downward force W, upward force tension equals to mass into acceleration. Simple. Net forces equals to mass into acceleration. That is what Newton's second law for linear motion. Are you getting the point? For rotation, why the rotation will happen? Because there is a point about which it will start rotating. What is the torque responsible? W into L by 4. Mass moment of inertia about the same point. Parallel axis theorem. And then alpha. Alpha value we have solved. Now acceleration will be R alpha, na, because it is trying to rotate like this. The tangential acceleration would be R alpha. That is nothing but tangential acceleration here. Acceleration answer we got it. We substituted here. Tension answer 4 by 7 W. That's it. I hope the solution is clear to everyone, right? If you have any doubt, please do comment, do mention in the chat box itself. We'll repeat it again for you. Okay, now coming to the next question, guys. Again, very important question here. So what is happening? 20-gram bullet traveling with 400 meter per second speed, it becomes embedded in 2 kg stationary block. What they are asking, determine the distance of the block will slide before it stops. So obviously it is moving with some velocity, it will some kinetic energy. With that it will also have some velocity and it will move further and it will eventually stop after some time. They are asking the distance it would travel before it is finally coming to the stop condition. Coefficient of kinetic friction they have given 0.2. Try to solve this question. I will give you a hint here. Apply the conservation of linear momentum principle so that you will get the velocity of the combined system when it start moving. Conservation of linear momentum. After that what you will do? After that what is the answer? What is the next approach? Use Newton's second law, calculate acceleration. That acceleration will be constant. Use V square equals to U square plus 2S. Distance and S you will be getting. If you put final velocity 0, initial linear velocity would be the velocity with which the both bullet and the block will be moving together. That would be the initial velocity. Final velocity 0. Why it is 0? Because we are saying ki it should stop, like it will eventually after some distance it has traveled, after that it will stop. So during that travel how much distance we have to calculate, that distance part. Final velocity would be 0, initial with which both are moving together, the velocity with which both are moving together. So that is the hint. So I will give you 3 minutes for this particular question as well, guys. So try to solve this one fast. So start solving everyone fast this question as well. Start solving everyone this question. I've already given you the hint. Apply conservation of linear momentum so that you will get a velocity of the system with which it start moving, right? And after that apply Newton's second law to get the acceleration, and then distance you will get the answer finally. Last 1 minute, everyone. Ten seconds left, guys. See, already I told you the hint also. What is happening here, that mass is going to hit this particular block and it's get embedded. Okay, both will get embedded. This basically this small bullet, 20-gram bullet is going to embedded in the block itself. After that, both will move together as single system. So conservation of linear momentum we will apply first. Conservation of linear momentum. Okay. Now, mass of bullet multiplied by velocity of bullet plus mass of block, capital B for block, okay, and velocity of the block equals to mass of bullet plus mass of block into the velocity with which it will start moving together. Now, see, very important point. Okay, the small b for bullet, I am using capital B for block. Right. Bullet 20 gram. So in terms of kg, 0.02 into velocity 400. It is initially stationary, the block, so velocity will be 0. Block mass they have given 2 kg. Bullet, okay, bullet it would be 0.2. So first I will write for bullet only 0.02 plus 2 into velocity v. Okay, from here velocity v you will be getting as the answer. Clear? Now that velocity we have to use, or we can say this is the velocity with which it will start moving together. Now second thing is apply the Newton's second law. So if I draw the free body diagram here for the block, see how it would look like. Okay, weight which is mg. How you will write mg? 2 plus 0.02 into 9.81. Correct? This is there. This is normal force. This is the friction force. Obviously it is moving, so kinetic coefficient of friction into normal direction will come. Right? That is there. Okay, this is acting, and now apply the Newton's second law directly. So acceleration mu k into n, mass into acceleration, mu k into n. N is mg. What is m? Again 2 plus 0.02 into g, that is 9.81. Mass again 2 plus 0.02 into acceleration ax. So this one this one get cancelled out. So acceleration ax will be opposite to the motion, we will use negative sign here. So negative acceleration mu k into 9.81. So they have given the values mu k 0.2. So acceleration minus 0.2 into 9.81. So finally acceleration ax answer will be getting minus, it is coming approximately 3 point something, we'll just calculate it, 9.81 into 0.2, it would be 3.96. okay, 0.2 it is there, it would be minus 1.96. 1.962 meter per second square. Okay, keep in mind this is negative acceleration, that shows the retardation. Negative acceleration means what? Retardation only, right? So this is ax answer now, and that will be constant value. For constant acceleration, what we will have, v square is equals to u square plus 2as. Final velocity anyhow it will be 0. Initially it would have how much velocity? Velocity calculation we have not done, so okay, let us calculate that part also. 0.02 into 400 divided by 0.02 plus 2, that is coming around 3.96. 3.96 meter per second. 3.96 meter per second square velocity, 2 into acceleration, which is minus 1.962 into distance s. So you will be getting 3.96 square, okay, divided by 2 into 1.962. So approximately this much distance you will be getting just by putting all those equations, right? Velocity 3.96, acceleration minus 1.962, like that. I hope the approach is clear. Conservation of linear momentum, then applied Newton's second law. After applying Newton's second law, we got acceleration is constant. For constant acceleration, v square u square plus 2s, this equation we have applied, and from this distance s we can easily calculate. If you have any doubt in this particular question, please ask in the chat box, guys, everyone. This is like very easy problem. Okay, you should not be facing that much issue in this particular questions. Tell me, is there any doubt here? Done? Okay, so you can solve here. It will be coming approximately 3.99. So you can say almost equals to 4 meter. That is what the answer you will be having. Right? Now look at the another problem that we are having. Yes, this one. This is also a very good problem. Okay. Now in this problem, again similar kind of problem, but different orientation, different modification they have done here. What is that? 10 kg block is held with some rest here. It is stationary condition. Now if 10 gram bullet is traveling with 300 meters speed, obviously it will get embedded here. Same thing they have mentioned. Determine the distance the block will slide up along the plane before the momentarily stopping, before coming to the stopping condition, like before it stop. So what you can do here, very basic thing, again conservation of linear momentum. While applying a conservation of linear momentum, please write your equation correctly, because the direction you have to ensure where it is moving along the incline, not horizontally. So you have to take the velocity component along the inclined plane. You have to take the velocity component along the inclined plane, okay, not horizontal. Then you will be getting a velocity with which both the bodies are moving together. And they are actually asking, see, this is very, very important point, because maximum time mistakes will happen because we are not keeping the directions. Formula you have used correctly, but direction you have not used correctly, then you will get wrong answer. So if you apply the conservation of linear momentum here, okay, so mass of bullet okay, multiplied by velocity of bullet along inclined plane. Along inclined plane you have to write. Correct? Biswajit, you have a doubt in parallel axis theorem. Tell me, yes, what is the doubt in parallel axis theorem? What is the doubt? We'll explain the parallel axis theorem. If you can tell me what is your doubt, then it would be much better. Otherwise, I will give you the whole explanation of the parallel axis theorem also. Okay, Biswajit? So this is the initial momentum of a bullet, initial momentum of a block, 0, because it is under stationary condition. Now, both will be moving together. What is the mass? 10 kg mass plus, this is 0.01 because 10 gram it is there. 10 gram, yes, 0.01 into velocity v. This is the velocity along the inclined plane you will be getting. Biswajit, what is the doubt in parallel axis theorem? Can you please explain or tell me what is the doubt? Okay, so mass of bullet, okay, let us write it here completely. 0.01, velocity is 300. Now, let us see, this is the velocity, but I need to write velocity in this component. Now, what is the angle? 30 degree. So, you will be writing here 300 cos 30. From here, V value will be getting. From here, yes, Biswajit, yes, after this problem, we will be talking about your parallel axis theorem doubt. Okay, just a moment here. What is the velocity V? Can you do the calculation here? We'll explain just after this, we'll explain the parallel axis theorem. Just do the calculation of velocity V first. What is the velocity V with which both will be moving together? This calculation you should do and let me know about your answer of velocity V. Can you do it fast, this calculation, everyone? This calculation of velocity V. After this, we'll talk about complete detail of the parallel axis theorem, okay, with some examples also. Approximately, if you see, the answer would be 0.2595. 0.2595 meter per second. And after this, what you need to do? They are asking the distance. You can basically apply the conservation of energy principle. Energy it would be having initially just after the impact, and when it going to move in the inclined plane, after some moment it will stop also. At that moment, whatever the energy it would have, that we have to write. So initially, I will consider this position itself as datum. So initial potential energy 0, but kinetic energy it is having, because initial velocity with which both are moving is 0.2595. When it stopped, it has acquired the potential energy, but kinetic energy becomes 0. So that conservation of energy principle we will be using. Conservation of energy principle. So potential energy initial, kinetic energy initial, potential energy final, kinetic energy final. So initial potential energy 0, half mv square kinetic energy, half mv. What is mass? 10 plus 0.01 multiplied by velocity that we have calculated 0.2595. Potential energy mgh, that is 10 into, okay, what is the mass we have to write? 10 plus 0.01 m into g, that is 9.81 into h. Final kinetic energy is 0 because it is finally it is going to stop. So from here h distance you can calculate very easily, and h is what distance? H is the distance it has travelled along the inclined not in the along the inclined plane, perpendicular distance. Because for writing potential energy, vertical height you will be considering, right? Vertical height. But let's suppose they are asking along the inclined plane. We can easily calculate this theta already we know. So sin theta is perpendicular upon hypotenuse. Okay, perpendicular upon hypotenuse you will be writing as sin theta. Perpendicular is what? H, hypotenuse is d. So distance d is along inclined plane, will be h by sin theta. This is along inclined plane. And this is vertical. Right? Clear? Now, Biswajit, let us discuss your doubt of parallel axis theorem. Okay, we'll discuss your doubt here. Now, as you are asking about the parallel axis theorem, please understand this application, how we can use this parallel axis theorem. Both in area moment of inertia as well as mass moment of inertia, both cases we will talk about. So that is the doubt of Biswajit. Please see. Let us consider there is a body we are having, and this is what its centroidal axis. This is what a centroidal axis, any centroidal axis it can be there, and this is another axis. Now Biswajit, please focus here, this is very important part. There is some body having its centroidal axis, and let us suppose the area of body is A. Distance between centroidal axis and another axis is D. Now if I have to write the area moment of inertia of a body about any other axis which is parallel to any centroidal axis of a body, then we can use this parallel axis theorem. And for that, what is the relation? Moment of inertia about AB equals to moment of inertia about its centroidal axis plus area of a body multiplied by distance d square. This is the formula from the parallel axis theorem, where it will be used whenever you want to calculate area moment of inertia of a body about any other axis, but condition is that axis has to be parallel with one of the centroidal axis, and moment of inertia about that centroidal axis you should know. Then only you will get the answer. Biswajit, any doubt here? Let us discuss one example with you. Okay, let me discuss one example with you. Right, see. This is the triangle we are having, and this is base B, this is height H. About, this is the centroid, right? Centroid distance from the base is H by 3. This is centroidal axis. Axis passing through centroid. Biswajit, are you able to understand this point? Okay. So centroidal axis, the axis passing through centroid. About centroidal axis, area moment of inertia is BH cube by 36. BH cube by 36. If I have to calculate area moment of inertia about this base AB, what I will do? I will write first area moment of inertia about centroidal axis BH cube by 36 plus area of a triangle half base into height multiplied by distance square of centroidal axis and the axis that I have selected for writing, that is H by 3. Biswajit, are you able to understand this part? There is a triangle, there is a centroidal axis, about centroidal axis area moment of inertia is BH cube by 36, but I want to calculate area moment of inertia about any other axis which is parallel to the centroidal axis. So this centroidal axis is there parallel to the centroidal AB axis I have selected. I want to write area moment of inertia about AB. What I will do, first area moment of inertia of centroidal axis plus this is what area of a triangle of a section and then distance square. Which distance square? Distance from the centroidal axis to the axis you have selected for writing moment of inertia. Accordingly, you will be getting area moment of inertia answer about any other parallel axis. One more example. Okay, let me give you one more example here. This is the triangle we are having. So this is dimension D, this is dimension B. This is x-axis, this is y-y axis, and this AB is the base. Again, Biswajit, please try to understand here about x-axis. What is the area moment of inertia? B d cube by 12. B d cube by 12, right? I want to calculate about AB. So what I will do, parallel to AB, x-axis axis, which is the centroidal axis. Parallel to centroidal axis, about AB, I want to calculate area moment of inertia. So first, I will write area moment of inertia about centroidal plus area multiplied by distance square. Okay, which distance square? This distance square. That distance would be half of d, that is d by 2. So we have to take d by 2 whole square distance here. Centroidal moment of inertia b d cube by 12. Area b into d, and then d square by 4. Like this. Biswajit, is it clear to you? Or like what is the exact issue that you are facing in this parallel axis theorem? BD cube. Okay, one more thing, Biswajit, here you should remember how to write moment of inertia about this x-axis. Maybe you will have a confusion, sometimes BD cube by 12, and for YY we have written DB cube by 12. For x-axis, which dimension will be cube? That dimension will be cube which is perpendicular to x-axis. Perpendicular to x-axis, which dimension is there? D. So D cube. For writing YY moment of inertia about YY axis, which dimension is perpendicular to YY? B. So B cube. Like that you should remember. Yes, Biswajit, you have written correctly, BD cube by 12, and then area also is there, na? Area of a body, complete body. Yes, absolutely, you have written correct answer. Is it clear, Biswajit? Now, I hope the discussion that we have done on parallel axis theorem is clear to you, right? So, built up section, Biswajit, that will be discussed in strength of material section. We are discussing the concepts related to engineering mechanics. That will come in strength of materials session. Don't worry about that, right? So today's session, whatever the numericals we have discussed, these are like very, very important numerical, guys. Again, I'm telling you, these are like very, very important numericals that you have to again practice it. Very, very important for the gate examination, right? So, will just before ending the session, I want to inform you regarding the test series product of IMS Gate Academy, and right now 20% off is there, and in that particular session, in this particular test series product, you will be getting more than 30 plus tests apart from 2 PYQ books you will be getting. Okay, one for aptitude and mathematics and one for your technical books. Okay, so this is there. Just a minute, moment, just a moment here. Just give me a moment, everyone. So there was a small technical glitch, guys. So I was telling about the test series product. As of now, 20% off is there, and you will be getting more than 30 plus tests. Apart from that, 2 PYQ books, one technical and one non-technical, where mathematics and aptitude you will be getting, right? Of all the branches, that is the most important part. For all branches, mathematics and aptitude questions you will be getting in that PYQ book. Doubt solving portal. At this moment, many students are worried about their doubts in numericals. So you can directly access the doubt solving portal, where you will be posting your doubts and you will get the solutions as soon as possible, right? And that is the most important feature. And just before the GATE examination, students are always worried about the doubts. So that is the feature which will resolve all your doubts, right? Apart from that, online sessions, GATE Booster series will be having. Post-GATE guidance, even after this GATE program, will be always with you. After the GATE program, based on your GATE score, what are the different possible opportunities you will have, that we will discuss in the post-GATE guidance program, right? And finally, mock interviews for PSUs and IITs also we will conduct here. So you can join this test series plus product and you can increase your preparation level. That is the most important part, because just because of this class notes and PYQ will not be sufficient to get a good score. You need to have a good test series product with you, so that you can practice and increase your level for the GATE examination, right? Now, second thing that I want to inform you guys is regarding the Telegram group, where you will be getting all free YouTube lectures PDF, as well as the latest notification of the all job recruitments in this Telegram group, and daily quizzes are running which will help you in your GATE preparation as well, right? So everything regarding the YouTube lectures, all PDF, everything you will be getting in this particular Telegram group. You can join. There is a link also provided in the description. You can directly click on that link and you can join the Telegram group. And finally, for GATE 26, the classes already started. If you are preparing for GATE 26, whoever in the right now in second year or third year, if they are starting the GATE 26 preparation, they can directly join IMS GATE Academy program. Or if you want to have a free counseling session, directly call on this number. You can book your counseling session. You will be guided about the GATE 26 program. And everything, whatever queries you will be having, that will be resolved in this counseling sessions. So in IMS GATE Academy 26, the live online program, you will be getting 12 one-to-one mentorship sessions. And these sessions are very important. Always you will have a direct connection with the faculty. Whatever challenge and the difficulty you will be go through in the preparation part, always faculty will be with you and he will try to resolve all your problems and the challenges in the preparation. Doubt solving portal, test series product, everything you will be getting. Apart from that, more than 800 hours of sessions of live classes you will be getting, and those live classes are interactive. You can directly discuss the doubt in the live class itself by audio chat, right? So I hope you have enjoyed the engineering mechanics GATE Booster series session. Tomorrow we will be having a session on thermodynamics. Please do join the session tomorrow, again same timing 4 to 7 p.m. for the applied and the basic thermodynamics sessions. Thank you so much, and if you have loved the session, please share this session with your friends as well. Thank you so much.